Now, last but not least, to conclude this section where you already learned a lot about Angular's router, I want to conclude this section by introducing you to route guards. The idea behind a route guard is in the end that you can define a function in modern Angular or in older Angular, a class that has a certain method that checks whether a certain navigation action should be permitted or not, so that in the end controls access to a route. And we could, for example, add such a guard here to our user tasks component route. And this guard will then guard this route and all its child routes. And you add guards to a route by using one of these can properties. Can activate child, can deactivate, or can match. Now, the most versatile guard you can set up is the can match guard, because this guard, in the end, allows you to control whether this entire route should be matched by a certain navigation action or not. So whether some path that has been entered into the URL should match this route or not. Can activate is somewhat similar, but comes one step after can match. The can activate route will be checked by Angular once a route has been identified as matching for the currently active path, but before the component here has been loaded. You'll therefore also often see can activate being used in Angular projects, but can match is a bit more modern. It has not been part of Angular right from the start and is a bit more versatile. So nowadays, if you want to control access to a route and its child routes, can match is typically the guard you might want to set up. Can activate child could be used if you want to activate this route here, this component, but not necessarily the child components of that route. But here I'll use can match. And all these can properties then take arrays. Arrays of guard functions or classes, though as mentioned, the class approach is a bit older. And I'll show you how to set up route guards as classes in the next lecture. In this lecture here, we'll focus on the more modern function-based approach of defining guards. And if you want to add such a can match guard to a route to control whether it's considered by Angular or not for an existing navigation action, if you want to do that with that function form, you do that by defining a new function anywhere in your application, in any file. In this case, I'll name it dummy can match, though typically you might want to have a more descriptive name, but here it is really just a dummy demo function. And the type here should be can match fn, and you should then store a function as a value in that constant. So that's a similar approach as I used it for the resolver function to get great TypeScript support. Now, a function qualifies as a can match guard function if it then takes two input parameters, where the first parameter is information about the route that you're trying to match or that you're trying to load. And the second parameter is a segments parameter, which is in the end an array of URL path segments. Now, inside of this guard function, you can then, for example, again inject things if you need access to some service or anything like that, for example. And you can then perform any logic of your choice in here. You can, for example, also work with observables or anything like that, because ultimately you should return a Boolean in here. True if you want to grant access to a route, or false if you want to deny it. Alternatively, you could also return an observable that yields such a Boolean. So that would be fine as well, just as with the resolvers. There you also could return data or observables that yield the data. Here it's the same with Booleans. For example, here we could use math_random to generate a random value between 0 and 1. And I'll store the result in a constant called should_get_access. And then we could check if should_get_access is true. In that case, I want to return true. Else, we might want to return false, or what you typically want to do if you don't want to grant access is you might want to redirect the user, because returning false would indeed deny access, but it would also kind of break the app because no route gets activated then in that case. So the user would kind of look at some broken page. So what you instead often might want to do is you might want to return a new redirect command here. And redirect command is something you can import from @AngularRouter. And it does what the name implies. You can use it to issue a redirect command, which will get Angular to navigate to a different page. And that's therefore what you typically might want to do instead of returning false, because these guard functions actually do not just allow you to return a Boolean, but also such a redirect command, or as mentioned before, a Boolean or this redirect command wrapped in an observable. Now this redirect command then needs a value of type URL tree as an input to describe the destination of the redirect. And you can easily create such a URL tree by injecting Angular router. So for that, you should inject the router, which is imported from @AngularRouter. Because that router then has a parse URL method to which you can simply pass a string path like /unauthorized or whatever you want here. And that will then be converted to such a URL tree. And that will ultimately then cause a redirect navigation to this path. Well, and with all that done, you can use this dummy can match guard function here and add it as a value to this can match array. Just as with the resolvers, you shouldn't execute these functions. Instead, Angular will do that for you, and you instead should just point at them. And you could also add multiple can match guards to one and the same route if you needed that. With that, I just want to tweak my code here a little bit, because at the moment, I'll always return true, because here I actually don't want to check whether that's truthy. It always will be, essentially, unless we really get just 0 as a result, which is unlikely. Instead, I want to check if we have a number smaller than .5, so that in 50% of all cases I grant access, and in the remaining 50% I redirect to unauthorized, which is a route we haven't set up yet, but therefore we should just see the not found fallback route. So with that, if you save that and you reload, you see I was redirected here, and now if I click around between my users, it sometimes works and it sometimes doesn't. And sometimes I get redirected to /unauthorized, and sometimes I instead see the user data. And that proves that this guard is working. Now, as I mentioned before, there also is can activate, which will run at a later point of time, after this route has been identified as matching, but before this component has been loaded. And then there also is can deactivate. And I'll best show you this route guard at the example of this new task component route here. The idea behind can deactivate is that you can control whether a user is allowed to leave a page or not. Now, to show you how the can deactivate route guard works, I'll go to that new task component. And then there in this file, below this class, I'll export a new constant called can leave edit page, or however you want to name it, which should be of type can deactivate fn. And then that will be a function that receives information about the component you're trying to leave as a first argument. Though you should add angle brackets here to let TypeScript know to which component this will be tied. So here you should insert your component class name, new task component in my case. And that's then what we'll get here as a first input parameter, the component instance which we're trying to leave. And you then also could accept a couple of other parameters with information about the current route, the current state of the router, and the next state that is expected if the navigation you're trying to trigger would be completed. Now here I only care about the component, but you could add all these other input parameters as well. Well, and since component is now that component instance which I'm trying to leave, we could, for example, access its properties and take a look at them and see if they contain any data that we might lose if we're navigating away. So we can check if component entered title, if we read that value, if it's truthy, or if component entered date is truthy, or if component entered summary is truthy. And if any of these properties is truthy, it means that it contains data that was inserted by the user, and that in turn means that we might not want to navigate away, at least not without asking. Now we can ask by calling window.confirm. So the confirm method is a built-in method that's provided by the browser that will open a confirmation dialog where the user can choose yes or no. And confirm will indeed return a boolean depending on whether the user did click yes or no. In addition, confirm takes a message as an input that will be shown as part of that dialog. So here we could ask, do you really want to leave? You will lose the entered data or anything like that. And as a result, as mentioned, we get true or false, and we can simply return that here as part of this guard function. If we're not inside of this if check, so if we have unchanged data, we can instead return true. So that then means that this guard function will always return true if the user has not entered any values, but if the user did enter values, we'll ask the user and will return true if the user chooses yes and false otherwise. And if we return true, the user is allowed to leave the page and Angular will go ahead and perform that upcoming navigation action, otherwise it will block it, essentially. Though only if we register this function as a can deactivate guard. So with it defined here, we should go back to our route definitions, to this new task route, and then there you can add the can deactivate property to this route definition. And just like can match or can activate, it takes an array of guards. And here it's then this can leave edit page guard function that you should add like this to this array. And just as before, you shouldn't execute it, you should just point at it. With that change made, if you're entering something here and you click cancel, for example, you see that you'll be prompted here. And if you click cancel, you'll stay on this page. It's only if you click OK that you will be navigated away. And that shows you how can deactivate works. It allows you to add a guard that makes sure that unintended page changes are prevented before they're even initialized.